Good day and welcome to another edition of Algebra 2 Notes with Miss Faust. Today we'll look at lesson 8.17.3. Our essential question is how can you use the value of one of the trigonometric functions to calculate the values of the other trigonometric functions. So this is when you're given sine, cosine, or tangent, then how do you find the other two? We'll start by looking at tangent, and what we use for these is we use things called identities. And as you progress in your math background, you will see identities more and more. But before we do that, I have a quick question for you. Do you know why the obtuse triangle was always upset? Because it was never right. Good one, huh? Get it? Right triangles? Okay, anyway, back to identities. So identities are things that always hold true, and so you can use them to find different parts of things. So if you think back to what we were doing with the unit circle in class last time, hopefully you remember that the sine of any angle theta is the same as the y-coordinate, and the cosine of any angle theta is the same as the x-coordinate on the unit circle. So this is from the unit circle. That says unit circle. You can't read it, but that's okay. So sine and cosine come from the unit circle, and then the tangent is always equal to y over x. Oops, the tangent of the angle is equal to y over x. Think back to the picture of the triangle if you need to for that. Tangent is opposite over adjacent, and if we're on the unit circle, right, it looks something like this. There's the circle, there's our angle, here's our y, here's our x, so tangent is y over x. But y over x is the same as sine over cosine. So if you know the sine and the cosine of an angle, you can always find the tangent. And that also means that if you know, the tangent and the cosine, or the tangent and the sine, you can find the third one. So we're going to use this so that we can find trig functions without having to find an angle. So that's our goal here, is find all three things without having to find an angle first. So example 1 would be the most basic. If you know the sine of some angle is 0.8 and the cosine of the same angle is negative 0.602, and you wanted to know what the tangent of the angle was, well, tangent is just equal to sine over cosine. So it would be 0.8 divided by negative 0.602. So you take out a calculator, you do 0.8 divided by negative 0.602, and you get negative 1.329. So that would be the tangent of your angle. And that's what we're looking for here. So now we've got the sine, the cosine, and the tangent is equal to negative 1.329. The other possibility is if, for example, you know the sine of an angle is 0.422, you know the tangent of the same angle is negative 0.466, and you want to know what the cosine of the angle is, well, then you just use the same formula. Tangent equals sine over cosine. But now we know tangent, we know sine, we're trying to find cosine, so we say negative 0.466 equals 0.422 over cosine of the angle. To get the cosine of the angle by itself, and you know what, I'm going to just do something here. I'm going to call this x. So what we're really looking at here is we're doing negative 0.466 equals 0.422 over x. A little easier to solve it then we're just solving for x instead of having to write cosine theta over and over. So I need to multiply both sides by x. I'm trying to get x by itself, remember. So I get x times negative 0.466 equals 0.422. And then I need to divide both sides by negative 0.466 to get x by itself. And when I do that, these negative 0.466s will cancel, and I'll get x equals negative 0.906. So the cosine, or the x value, of the angle equals negative 0.906. So I have found the cosine. I now know the sine, the tangent, and the cosine of the angle. And that's my goal in these, is always to find all three. So maybe now you're thinking, okay, great, Miss Faust, that's all well and good if I know the sine and the cosine, or I know the sine and the tangent. But what if I only know one thing? Like, what if I only know the sine? Can I still find the cosine and the tangent? And the answer, of course, is yes. And let's think about why. So what we're going to do, this is actually going to develop a new identity. So it's kind of a little mini proof, not a formal proof, but it'll help you understand where this comes from. So think about the unit circle again, and I'm just going to draw part of it so I'm going to work in this 0 to 90 section. I can't draw a whole circle, so why make my life harder than it needs to be, right? So if we imagine some triangle, and we can put that angle anywhere we want, but we put a triangle inside the unit circle. Well, if this is the unit circle, here's my angle theta. Because it's the unit circle, my radius has to be 1. And because it's the unit circle, I know that this point has coordinates x, y. This side is y, this side is x, because that's the x and the y. And then hopefully, if you look at that and you think about the relationships between those, you can see that x squared plus y squared has to equal 1. Or we could write it the other way. Y squared plus x squared equals 1. Right? Both of those mean the same thing. But if we think about that a little bit more, the fact that we're on the unit circle means that the x is the cosine of the angle and the y is the sine of the angle, whatever this angle is. So what I can do is I can replace this y with sine theta, and then I can replace the x with cosine theta. And I still need to keep the squared and the plus and the squared and the equals 1. And that brings us to another Pythagorean identity. Because now, if you knew the sine, you could solve for the cosine. Once you know the cosine and the sine, you can find the tangent, and vice versa. You will not usually see this written like this. The way you'll see this written in books and online and everywhere is that the sine squared of something plus the cosine squared of something equals 1. This is called a Pythagorean identity. And it's called that because it comes from the Pythagorean theorem. So this identity is one of the most used in trigonometry, and the reason is because it's so common. And it's so common to need to find other sides, and it makes it really easy to do that. So sine squared plus cosine squared equals 1. Put some stars and bells and whistles around that. I guess you can't put whistles in your notes, but you know what I mean. So let's look at how that works. So for example, what example are we on? Example 3. If we know the cosine of an angle is 0.707, and we want to find the sine of the angle. So we're just going to keep it simple to begin with. The first thing that we have to realize with this, so we would have the cosine equals 0.707, but we'll also always be given one more piece of information, and that is something about where the angle lies. So if this says it's where the angle is greater than 0 and less than pi over 2. So if you think about a little mini unit circle, that means that the angle is somewhere between here and here. And that becomes really important because that's going to tell us at the end whether our answer is positive or negative. So here in quadrant 1, right, our sine and cosine are both positive. So that's going to be important, and you'll see why in a minute. So if we're trying to find sine, we're going to go back to this identity. We're going to start by saying sine squared theta plus cosine squared theta equals 1. Well, what we know is the cosine. So this is going to go right here. And the way I write that, we have to be a little bit careful here because this 0.707 is replacing the cosine of theta, but it still needs to get squared. So I'm going to put it like that. Sine squared plus 0.707 squared equals 1. Now I just need to solve this for sine. So first I subtract 0.707 squared from both sides. And I'm just leaving this for now. Eventually, I'll actually put this in the calculator, but it's going to be easier if I can eliminate extra decimals as much as possible. These two cancel. I'm left with sine squared theta equals 1 minus 0.707 squared. And then to solve that, I'm going to need to take the square root of both sides. So again, you can put that all in your calculator at once. You do the square root, you put some parentheses, you do 1 minus parentheses 0.0707 close parentheses squared. Take the square root of all that, and what you'll get is you'll get 0.707. That's not an accident, this just happens to have the same answer as what we started with. Now remember, when you take the square root, you could have a positive or a negative answer. Calculator will only give you one, but anytime you take a square root, you can have a positive or a negative. And then that's where this piece comes in, because this piece tells us that the sign is positive. So I know that the answer to this is positive 0.707. Okay. If I had been in a quadrant where my sign was negative, then I would only have a negative 0.707 here. Okay, so that part always comes in at the end, this part out here, and it tells you whether your final answer for the sine and cosine is going to be positive or negative. It also works for the tangent. So let's do another one of those. So, questions, notes, example 4, and this will probably be the last example for today, because I think then you'll be able to get the hang of it enough to try it in class. So sine of theta equals negative 0.866, where theta is between pi and 3 pi over 2. So we'll leave that part alone for now. We'll come back to that at the end. What we want to do here is we want to find cosine theta and tangent of theta. So we're going to start by finding cosine. In order to find cosine, we use that same sine squared theta plus cosine squared theta equals 1. So again, this time I know the sine, so that's going to get replaced right there. So this becomes negative 0.866 squared plus cosine squared theta equals 1. Want to get cosine by itself, so I subtract negative 0.866 squared, and I subtract negative 0.866 squared. You want to be really careful and watch the signs on these as you do this, because this one ends up being squared, so you still have 1 minus there. So just keep track of them all as you go. Write them all out, and that way when you go to put it in the calculator, you'll be on the right track. Okay, and then we take the square root of both sides. And again, you can plug that all in your calculator at once. The square root, I don't usually do it all at once. I usually do 1 minus parentheses negative 0.866 parentheses squared, enter, and then I do the square root of the answer. And when you do that, you will get approximately 0.5. So remember that since we took a square root, we could have a positive or a negative answer. And now to determine if it's positive or negative, that's where we have to go back and we have to look at that extra piece of information we have. So again, here's our mini unit circle. I like to just draw it always. It's helpful for me to see it that way. So then you might look at this and go, well, I remember this is ASTC, where this is all positive, this is sine positive, this is only tangent positive, and this is only cosine positive. And then this is between pi and 3 pi over 2. So from 0, here's pi over 2, here's pi, so this is where my angle starts. Here's 3 pi over 2, so my angle is somewhere in that region, which means only tangent is positive, which tells me my cosine is negative. So that means that from here, the cosine of theta is equal to negative 0.5. Last thing I need is the tangent, because I'm looking for cosine and tangent. Well, tangent is equal to sine over cosine. My sine is negative 0.866. My cosine is negative 0.5. So I plug those both in and I get negative 0.866 divided by negative 0.5. Sorry, I had to go grab my calculator. 1.732. Notice that that's positive. We're in this quadrant, so my tangent should be positive. So I know now my cosine is negative 0.5 and my tangent is 1.732. Okay? Thank you very much for your attention. I will see you in class soon.